Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC, MLR Institute of Technology. In the last video, we already discussed about the planar graphs in discrete mathematics. The next topic is Euler's formula. So, what is meant by Euler's formula? How to evaluate the number of vertices, number of edges, number of regions using the Euler's formula, and we can understanding this Euler's formula by considering some examples. So what is the Euler's formula? If G is a connected planar simple graph, that means the graph which is to be connected. Connected means there is a communication line or edge is present. It is a connected graph and it is a planar graph and it is a simple graph because no edges are crossing and each and every vertex is connected and it is a simple graph. And what it consisting of? E edges. That means E is 4 edges are present and 4 vertices are present and or number of regions are present. Then we can say that the planar representation of G is R equal to E minus V plus 2. Why we have written 2 means there are 2 regions. One is inside of the graph is one region. Another one is outside of the graph is another region. That's why for any graph maximum 2 regions are possible. That's why in the formula itself it is written as R equal to E minus V plus 2. That is E equal to number of edges, V equal to number of vertices and R is the number of regions. Then R is a, with the help of R we can find how many vertices, how many edges, how many regions. Anything we can calculate with the help of the Euler's formula. That's why R equal to E minus V plus 2 is called as the Euler's formula. Let us consider the first example. Let G be a connected planar simple graph with 25 vertices and 60 edges. Find the number of regions in the given graph. What is the formula for number of regions according to the Euler's formula? The Euler's formula is R equal to E minus V plus 2. How many vertices are present? 25 vertices. How many edges is equal to 60? We need to find out the R value. There is a only vertices and edges are given in the formula. Directly we have to apply the Euler's formula R equal to E minus V plus 2. Edges is 60. Number of vertices is 25 plus 2. 60 minus 25 is 35 plus 2. R is equal to 37. Total 37 regions are present in the graph. If there are 25 vertices and 60 edges, there is a maximum 37 regions are present in the given graph. That is the example for Euler's formula. Consider one more example. Let G be a planar graph with 10 vertices, 3 components and 9 edges. 3 components and 9 edges. Find the number of regions in the given graph. So, suppose there is a components are given in the problem. Components are given in the example. Then how to find the number of regions? There is a separate formula, that is R equal to E minus V plus K plus 1. If K components are given, then we have to apply this formula. If the K value, number of components are not given, directly we need to apply the formula as R equal to E minus V plus 2. If K components are given, you have to apply K plus 1. Total how many number of vertices? V is equal to 10. Total number of vertices are 10. Next, how many number of edges? E is equal to 9. How many number of components? That is K is equal to 3. Next, we need to apply the Euler's formula R equal to E minus V plus K plus 1. That is K plus 1. So this is called as a generalized Euler statement. This is called as a generalized Euler's statement. According to this formula, then we have to substitute the values of edges, vertices and components. We have to find the number of regions. How many edges are there? 9 edges. 9. How many number of vertices? 10 plus k plus 1. That is number of components are 3 plus 1. 9 minus 10 is minus 1. 3 plus 1 is 4. Plus 4 minus 1 will get 3. Total number of regions in the given graph G is equal to 3. Suppose the graph consisting of 9 edges, 10 vertices, then there exist 3 regions in the given graph. Consider one more example. Let G be a connected planar simple graph with 20 vertices and degree of each vertex is 3. Find the number of regions. So, we don't know what is E, number of edges, but vertices has given. So, we need to apply one more theorem called sum of the degrees of theorem. By using the sum of the degrees of vertices theorem, we have to find the number of regions, number of edges. Once we know the number of edges and number of vertices, then it is easy to find the number of regions. So, what is the input that has given number of vertices? That is V equal to 20. Then, what is the number degree of each vertex? That is equal to 3. So, once we know the number of vertices and the degree of each vertex, we need to apply the number of edges. We need to calculate the number of edges. What is the formula to calculate the number of edges? By using the sum of the degrees of vertices of the theorem. According to the sum of the degree of the vertices is equal to total 2 into total number of edges. How to find the sum of the degrees? Number of vertices into degree of each vertex. How many number of vertices are present? How many number of vertices are present? 20. What is the degree of each vertex? 20 into 3. That is equal to 2 into total number of edges. We don't know what is E value. 2 into E. From this, we need to calculate E value. 20 into 3 is 60 is equal to 2E. Then what is E? E equal to 60 by 2. That is 30. That means number of edges. Once we know the number of edges and number of vertices, we can find out the number of regions by using the Euler's formula. R equal to U E minus V plus 2. Number of edges are, that is 30. Number of vertices are 20 plus 2. That is 30 minus 10 is 20. 30 minus 20 is 10 plus 2. Are equal to 12. Total 12 regions are present if the graph consisting of 30 edges and 20 vertices. R equal to U minus V plus 2. 30 minus 12 will get 12. Total number of regions are 12 that is present in the given graph. Considering one more example, suppose G is a connected planar graph with 14 regions. Each of degree is 4. Find the number of vertices. In the previous example, we have to find the number of vertices. Now we need to find the number of edges. So if not vertices or maybe edges are not given, then we have to easily find out by using the sum of the degrees of the theorem. So sum of degree of R equal to 2 mod E. 2 into number of edges. Number of edges. That is degree of R. R is nothing but regions. That is 14 regions are present. What is the degree of each region? 4. 14 into 4 equal to 2 mod E. So what is mod E? Means total number of edges. That is 56 is equal to 2 mod E. Then mod E equal to 56 by 2. That is equal to 28. Once we know the number of edges, then we have to substitute in the Euler's formula to find the number of vertices. So what is Euler's formula? R equal to mod E minus mod V plus 2. So mod R is already given, that is equal to 14. Mod E equal to 28. We need to find the number of vertices mod V plus 2. That is mod V equal to 28 plus 2 minus 14. That is 28 plus 2 is 30 minus 14. Mod V is equal to 16. That is the total number of vertices. If total number of vertices, total number of edges can be substituted in the Euler formula, we will get number of regions. We need to verify the answer with the help of the number of vertices. Mod R equal to mod E minus mod V plus 2. What is total number of edges? 28 minus 16 plus 2. 28 minus 16 is 12 plus 2. Total number of regions is 14. So, number of edges are correct. Number of vertices are correct because number of regions are 14. We'll get in reverse, we'll get 14 regions. So, that is Euler's formula. Up to now, what we have discussed, what is meant by Euler's formula. With the help of Euler's formula, we have to find the number of vertices, number of edges, and also with the help of using generalized statement, we have to find the number of regions. Everything is possible with the help of the Euler's formula. And also we considering some examples how to find the number of vertices in the graph, how to find the number of edges in the graph, how to find the number of regions in the graph. Thank you.